In this video, we're going to focus on solving systems of equations by the elimination method, also known as the addition method. So consider this example. 2x minus y is equal to 3, and 3x plus y is equal to 7. How can we solve these two equations? Whenever you have two variables, you need two equations to solve for those two variables. So if you have three variables, you need three equations. In this video, we're going to go over an example where we're going to solve a system with two variables and three variables. Now, what you want to do is you want to cancel a variable. Notice that if we simply add the two equations, the y variable will cancel. 2x plus 3x is 5x. Negative y plus y is 0, so they simply disappear. And 3 plus 7 is 10. So now what we need to do is divide both sides by 5. 10 divided by 5 is 2. So now we have the x value of 2. So at this point, we need to substitute x with 2 in any one of the two equations. Let's use the first one. And let's solve for y. 2 times 2 is 4. So we have 4 minus y is equal to 3. Let's subtract 4 from both sides. So negative y is equal to 3 minus 4, which is negative 1. Now the next thing that we need to do is we need to divide both sides by negative 1. Negative 1 divided by negative 1 is 1. So y is equal to 1. So therefore our answer as an ordered pair is 2, 1. So let's check the answers to see if they're correct. So we have two equations. 2x minus y is equal to 3, and 3x plus y is equal to 7. And the answer we said was 2, 1. So if we plug in this point into both equations, and if the left side has the same value as the right side, then we know for sure that we have the right answer. So x is equal to 2 and y is 1. 2 times 2 is 4, and 4 minus 1 is 3. So this solution works for the left side. Now let's check the other equation. 3 times 2 is 6. 6 plus 1 is 7. Since 7 equals 7, this equation is okay. So the point 2, 1 is correct. Let's try another example. 3x plus 4y is equal to 15, and 2x plus 3y is equal to 11. Feel free to pause the video and see if you can solve this equation. And once you finish doing so, unpause the video to see the solution and see if you have the right answer. So right now we can't just add the two equations because neither variables will cancel. So we need to modify the equation. So you have to choose, do you want to cancel x or y? It might be easier to cancel x because the numbers in front of x are smaller than the numbers in front of y. Let's multiply the first equation by 2 and the second one by negative 3. The reason being is if we multiply the first equation by 2, 3x times 2 is 6x. And if we multiply the second equation by negative 3, 2x times negative 3 is negative 6x. When you add 6x and negative 6x, they will cancel, which is what we want. So 3x times 2, we said, is 6x. We need to distribute the 2 to every term. So 2 times 4y, that's going to be 8y. And then 2 times 15 is 30. Now let's do the same thing with the negative 3 in the second equation. 2x times negative 3, that's negative 6x. Negative 3 times 3y is negative 9y. And negative 3 times 11, that's negative 33. Okay, so let's add the two equations. 6x and negative 6x will cancel. 8y plus negative 9y, that's the same as 8 minus 9. This is negative y. 30 plus negative 33, or simply 30 minus 33, that's negative 3. So if we multiply both sides by negative 1, negative 1 times negative y is y. Negative 3 times negative 1 is positive 3. Therefore, y is equal to 3. Now we can use any one of these equations to solve for x. So let's use the very first equation in its unmodified form. So 3x plus 4. Let's replace y with 3, and let's solve for x. 4 times 3, that's 12. And in the next step, we need to subtract 12 from both sides. So what we have left over is 3x is equal to 15 minus 12, which is 3. And then we need to divide both sides by 3. 3 divided by 3 is 1. So therefore, x is equal to 1. So the solution is 1, 3 as an ordered pair. And you can plug in x and y into the original two equations to see if the left side has the same value as the right side, to know if it's correct. Try this one. 1 over 3x minus 1 over 2y is equal to negative 2. And 1 over 6x plus 1 over 4y is equal to 3. So if you have a system of equations with two variables and fractions, what do? Well, let's take it one step at a time. Let's clear away the fractions before we try to cancel any variables. So what is the least common multiple of 3 and 2? The least common multiple of 3 and 2 is 6, because 3 and 2 both go into 6. So we're going to multiply everything by 6. Now let's distribute the 6 to every term in this equation. So what is 6 times 1/3 x? 6 times 1/3 is the same as 6 divided by 3. So that's going to be 2x. Now what about 6 times a half? 6 divided by 2 is 3, so we have negative 3y. And then finally, 6 times negative 2 is negative 12. Now for the second equation, what number should we multiply both sides to get rid of the 4 and the 6? We need to clear away the fractions. We can use 24, but 12 is better because it's smaller, and 4 and 6 can go into 12. So what's 12 times 1 over 6? 12 divided by 6 is 2. So we have 2x. And if we multiply 12 by 1/4 y, 12 divided by 4 is 3. So we have 3y, and 3 times 12 is 36. Now notice that if we add the two equations, the y variables will cancel at this point. Negative 3y plus 3y is 0. 2x plus 2x is 4x. And negative 12 plus 36 is the same as 36 minus 12, which is 24. So since 4x is equal to 24, to solve for x, we need to divide both sides by 4. So 24 divided by 4 is 6. Therefore, x is equal to 6. So now we got to find y. We really don't want to use the equations with the fractions, so let's get rid of it. Let's use this equation. So let's replace x with 6, and let's solve for y. 2 times 6 is 12. And to isolate y, to get it by itself on the left side, we need to subtract both sides by 12. So what we have now is negative 3y is equal to negative 12 minus 12, which is negative 24. So if we divide both sides by negative 3, we can see that y is 24 over 3, which is 8. Whenever you have two negative numbers either multiplied or divided by, it's going to become a positive number. So the answer is 6, 8. So let's check our answers with the original equations. So the first equation was 1 over 3x minus 1/2 y, and that was equal to -2. So let's replace x with 6 and y with 8. Let's see if the left side is the same as the right side. 1/3 of 6, or 6 divided by 3, that's 2. Half of 8 is 4. And -2 is the same as 2 minus 4. 2 minus 4 is -2. So the left side equals the right side. So this is good so far. Now let's check the other equation. 1 over 6x plus 1/4 y is equal to 3. So let's replace x with 6 and y with 8. 6 divided by 6 is equal to 1. 8 divided by 4 is 2. And we know that 1 plus 2 is equal to 3. So this is the right answer to the problem. Now what if we have a system of equation with three variables? So let's say that x plus y plus z is equal to 6, and 2x plus y minus z is equal to 1, and 3x minus y plus 2z is equal to 7. Since we have three variables, we need three equations to solve for these three variables. Now the first thing that you want to do when solving a three-variable equation, you want to choose a variable that you want to cancel. Is it easier to cancel x, y, or z? Think about it. Personally, I think it's easier to cancel y. Z would be my second option, but notice that we have a 2 in front. With y, we don't have any coefficient. We just have y, negative y, which is going to be a lot easy to work with. So let's choose y. Now you want to pick two equations out of the three to add. Let's number the three equations. Let's call this one equation 1, equation 2, and equation 3. So I'm going to choose equation 2 and 3. I'm going to add those two. So the y variables will cancel. 3x plus 2x is 5x. Negative z plus 2z, that's simply z. And 1 plus 7 gives me 8. So I'm going to save this equation. 5x plus z is equal to 8. So keep in mind, I've used equation 2 and 3. Now, I need to use equation 1 either with equation 2 or with equation 3, but I have to use equation 1. I need to choose two other equations where y is canceled. I have to cancel the same variable. I can't switch and cancel x or z. Because I use equations 2 and 3 to cancel y, I need to choose another two equations and cancel the same variable so I can get another equation with x and z. Now I have to use 1. Is it better to use 1 and 2 or 1 and 3? I think it's easier to use 1 and 3 because the y's will cancel. They have opposite signs. So I'm going to rewrite it first. X plus y plus z is equal to 6. That's equation 1. And then I'm going to write equation 3 right below it. 3x minus y plus 2z is equal to 7. So let's add these equations. The y variables will cancel. X plus 3x is 4x. Z plus 2z is 3z. And 6 plus 7 is 13. So now I have two equations with two variables, highlighted in green. Now at this point, I need to combine those two equations that contain x and z. So I have to choose another variable to cancel. Should we cancel x or should we cancel z? what would you say? Since z has smaller coefficients, personally I believe it's easier to work with that. Let's multiply this equation by -3. If we do so, the z's will cancel. I'm going to put the -3 here, so I can rewrite the equation right below this one. -3 times 5x is -15x. -3 times z is -3z. And -3 times 8 is -24. So now we can add these two equations. 4x plus -15x, that's the same as 4 minus 15, which is -11. The z variables will cancel, and 13 plus -24, which is 13 minus 24, that is -11 as well. So at this point we can divide both sides by -11, and so we could see that x is equal to 1. So now let's save this answer. So now what we're going to do is we're going to plug in 1 into this equation and find z. So 5 times 1 plus z is equal to 8. 5 times 1 is 5, so 5 plus z equals 8. If we subtract both sides by 5, 8 minus 5 is 3, so therefore z is equal to 3. So now that we have x and z, we can use one of the 3 original equations to solve for y. So first, let's make some space. Let's clear away the right side since we no longer need it. Let's use the first equation because it's easier to deal with. There's no coefficients. So since x plus y plus z is equal to 6, if we plug in the numbers that we have, 1 plus y plus 3 is equal to 6. 1 plus 3 is 4, so y plus 4 is 6. If we subtract both sides by 4, we can see that 6 minus 4 is 2, so y is equal to 2. So our answer is 1, 2, 3 in the form of x, y, z. Now, for the sake of practice, let's try another problem like this. Try this one. So 2x minus y plus 3z is equal to 15, and 3x plus 2y minus 4z is equal to 11, and 4x minus 3y plus 2z is equal to 14. So the first thing we need to do is determine which two equations we want to use and also which variable we want to cancel. Is it easier to cancel x, y, and z? I'm going to go with y again. Let's use equations 1 and 2. So to cancel y, all I need to do is multiply equation 1 by 2. So it's going to be -2y plus 2y, and they're going to cancel. So let's do that. Let's multiply this equation by 2. So 2x times 2 is 4x. -y times 2 is -2y. 3z times 2 is 6z. And 15 times 2 is 30. Now the second equation, I don't need to change anything. I'm just going to leave it the way it is. So now we can add the two equations. So the y variables will cancel. 4x plus 3x is 7x. 6z minus 4z is 2z, positive 2z. And 30 plus 11 is 41. So here's the first equation with two variables. So now I need to use equation 3, and I have to cancel y again. So personally, I think it's easier if we use 1 and 3, because I only need to change equation 1. I don't have to change both 1 and 3. So this time, I'm going to change equation 1. I'm going to multiply it by -3, so that I would have positive 3y and negative 3y. So multiplying the first equation by negative 3, 2x times negative 3 is negative 6x. Negative y times negative 3 is positive 3y. And 3z times negative 3 is negative 9z. And 15 times negative 3, that's negative 45. You have to be careful with every step, because if you make one mistake, just one mistake, this entire problem is ruined and you have to rework the whole thing. So always be very careful. Patience pays off in the long run. So now, let's multiply equation 3. Actually, we don't need to multiply equation 3. Let's just rewrite it. So if we add it, we can see that the y variables will cancel. Negative 6x plus 4x is negative 2x. Negative 9z plus 2z is negative 7z. Now what about negative 45 plus 14? How much is that? That's the same as 14 minus 45, which is negative 31. So now we have two equations with the same variables, x and z. So what do we need to do in this case? What would you recommend? Should we cancel x or should we cancel z? It really doesn't matter which option we choose, but let's go ahead and cancel x. So 7 and 2, the common multiple is 14. So we're going to multiply this equation by 2 and this equation by 7. So 7x times 2 is 14x. 2z times 2 is 4z. And 41 times 2 is 82. Now for the other equation, that's this one, negative 2x times 7 is negative 14x. Negative 7z times 7 is negative 49z. Now what's negative 31 times 7? 30 times 7 is 210 because 3 times 7 is 21. You just got to add a 0. 7 times 1 is 7. So 210 plus 7 is 217. So we have negative 217. Now let's clear away some space. We don't need this side right now. So let's get rid of it. And let's add these two equations. What is 14x plus negative 14x? We know that cancels. And what about 4z minus 49z? 4 minus 49 is negative 45. And what's 82 minus 217? If we subtract it backwards, 217 minus 82, let's see what happens. 7 minus 2 is 5. 1 minus 8 is negative, so let's borrow a 1. The 1 is going to turn into 11. 11 minus 8 is 3. And 1 minus nothing is 1. So if 217 minus 82 is 135, then 82 minus 217 must be negative 135. So now let's divide both sides by negative 45. How many times does 45 go into 135? It turns out it goes into it 3 times, which means that z is equal to positive 3. So now what we're going to do is we're going to plug in z into this equation so we can find the value of x. So 7x plus 2 times 3 is equal to 41. 2 and 3 will give us 6, and 41 minus 6 is 35. 35 divided by 7 is 5. Therefore, x is equal to 5. Now that we have x and z, let's solve for y. And let's use the first equation since it has the smallest coefficients. 2 times 5 minus y plus 3 times 3 equals 15. 2 and 5 is 10. 3 and 3 is 9. 10 plus 9 is 19. And if we subtract both sides by 19, we can see that negative y is going to equal negative 4. So if we divide both sides by negative 1, y is equal to positive 4. Therefore, we have our answer. So x is 5, y is 4, z is 3. So as a pair, we can write it as 5, 4, 3 in terms of x, y, z. So that is the answer to this problem, and that is it for this video. So thanks for watching and have a great day.